So the Solar Design and Training Company, we've been representing Pixpro now for United Kingdom and Ireland. We've been involved with the UK solar industry, providing simulation software for now some over 30 years. The use of aerial, unattended aerial vehicles, UAVs, or just most people will say drones, with high resolution cameras for surveying sites intended for PV installations has come to the forefront. And it's a logical step to create 3D models from such images. And we're going to show you about creating those images and importing them into PVSol. We've got another webinar, by the way, later today at midday, which we're going to spend much more time on PVSol. So when we're talking about PVSol this morning, we're going to keep it quite short. So if you feel like you want more information about PVSol, come back at midday. If you haven't got a link, just get in touch with us and we'll send you a link. So I'm very happy to introduce my co-host today, Andreas Guzatis. There's a picture there of Andreas. Andreas, are you with us? Are you there? Could you open your mic, please?
Yes, Christopher, hello, and hi to everybody attending.
Okay, excellent. We have communications. I'm going to make you a presenter in just a second, and then you will have the ability to show us a little bit more information about Pixpro.
Lovely. Okay. There we go. Let me know when you see my screen.
Yes, I can see it fine, Andreas.
Lovely. Okay, so thanks again for the opportunity to represent my company. We are Pixpro. We are based in Lithuania, and we've been around for nearly 10 years. We are a software development and research company, and we specialize in photogrammetry, mapping, and similar software products. Our main focus of industry is energy generation. So in that regard, photovoltaic industries is very much in our focus. Also mining and defense, which are a bit less important in today's conversation. So without much further ado, let me introduce our software, which is also called Pixpro. So on the opening screen, we have 4 choices, or actually 2 choices and a little bit of information. So we can choose to do our project either on local computer or on the cloud machine. Depending on your choices, the procedure is more or less the same. We also here in the lower part have a possibility to open previous projects, and we can see if we have any cloud tasks ongoing at the moment. Let's go for the new project. So we are going to use a shopping center, shopping mall. So I'll just call the new project simply shop. I'm okay with the folder choice and coordinate system. So simply click next and go to the next screen. This is where we choose the photos, which we usually take with a drone or UAV. And for that, we can choose either to choose individual photos or the folder. I decided to go for the folder because I have it in separate folder, all the photos I need. Select folder. Photos are being uploaded into the software. Let's just wait for a second. And here we go. There we have an opportunity to have a quick look at the photos. And since we can clearly see that these are of the shopping mall, we say okay with that. Now, this is the part where the photos are both copied into the project folder and also inspected for the EXIF information, in particular for the information of coordinates collected during taking of the photos, because nowadays almost all drones have a possibility to attach coordinates. Coordinates are important first, of course, to have correct measures on the reconstruction. At the later stage, I'll show how we can check those. And also we have an opportunity to see whether our reconstruction is placed correctly towards the south, north, east, west axis, which is also important in the photovoltaic generation. All right. Our import is nearly done. As you can see, I'm using quite a lot of photos in this case, 375. For the personal house, usually is quite enough, something between 30 and 50 photos. But for the larger building, we may need more photos. Just a quick note, when we have photos placed on the map, we can also see if we have any outlying photos which can be bad for the reconstruction. Like this one here on the right, we can also see that it doesn't have any pictures of the building in question. So on the very next step, here on the left, we can see that we have quite a few layers in advance. On the very next step, which is to do a structure reconstruction, I'll interrupt myself here shortly. We can do that in 3 different manners. We can do it step by step by ourselves. Here at the menu, as you can see, I have to recreate structure to do any other tasks. Or we can go for the full workflow, which opens for us the menu where we can choose which layers we want to have. Since our target is to generate mesh, we can leave everything up to the mesh and disconnect everything else and just say start batch, or we can go bit by bit. Also, the third option is still go for the cloud processing. Never mind that we chose the local project. You can change your mind at this stage as well. Let's go for the step by step so we can see them more clearly. There we have quite a few options. I would suggest leaving most of them as they are in automatic possibility. And only thing is select photos. Yet again, if we have some photos in the which we probably don't want, we can uncheck them all and choose either from the list photos, or we can say that we want, excuse me, a little bit too much of a zoom, choose a selecting tool here on the right hand side corner and say that, all right, we want only these photos. Then not to forget to check them, say OK, and say start. This process may take quite a while, especially with so many photos. So I'm not going to wait for it, and I'm going to do a little bit of cheating and then just jump into the project which is already reconstructed. So right after that, what we get is a so-called sparse point cloud. This is your general reconstruction. As you can see, in this particular case, since we had a lot of photos and a lot of matching points, we can barely see something recognizable. More often than not, it would be quite unrecognizable for the human eye, but this is done only for the computer's benefit, so to speak. The next thing we want is the dense point cloud. So we can get that as soon as we have sparse point cloud, either by clicking right-hand button on point cloud and choosing generate dense point cloud, or yet again going into the workflow and choosing the same option here. After that, computer software will generate for you a dense point cloud, which is much more recognizable for the human eye. And now we can see that we have both shopping mall and quite a lot of area around, which we have no use in this particular case. We can see no quite tall buildings or trees around, which can impact our photovoltaic battery. So what we want to limit the size of the mesh which we are going to generate. So here, right on the top and on the top and right-hand side of it, we can see that we have a clipping box. And there simply we can reduce the size of our reconstruction and a little bit more here. Oops, wrong button. Here, reduce this one a little bit more from this side, from here, and probably even from the bottom. Yes, that's much more manageable. If we zoom in now, we can see that we have only building and just a little bit area around. I keep clicking on the wrong button, so let me correct myself. There we go. And all we have to do just to click OK here on the right hand side lower corner, and what we will get will be the cropped point cloud. Turn this off. As you can see, it's much more manageable, much smaller, and only has what we need. After that, we have to generate mesh, because mesh is the part which we can actually import into PVSol software. You can export any of these layers from the Pixpro, but only mesh is really important if you are going to work in PVSol. So yet again, you can choose either right-hand side click on mesh tab and generate mesh, or do that from the workflow. When you are generating mesh for the PVSol, point to remember is that PVSol does not support a big amount of triangles. Our software can easily generate mesh with about 2 million triangles, which is way too much for the PVSol, and you really don't need that because we are looking at a lot of flat spaces anyway. We recommend trying 50,000 first. If you are quite happy with the speed of your machine, you can increase to 60, maybe 70,000. If your machine is struggling to work on with that so many triangles, you can reduce to 40, maybe 30,000 triangles. But I would recommend to start with 50,000. Okay. And also in this case, we have to choose textures. And texture properties also quite important. Yet again, for the PVSol, the best choice is 4000 by 4000 pixels texture size, and make sure to choose one atlas as an atlas limit. These are also quite important. All right, and then we click start, and what do we get is the mesh. Let me click on that, and as you can see, it's quite nice reconstruction of the building. Now what we should do is to check the measurements, because mostly it will be okay, but it never hurts to check. So if we expand objects tab, we have here an option for lines. So right click on that, add line. And one of the simplest ways is to choose anything you are quite happy that you know the actual distance. So for example, these parking lots are each 2.5 meters width. So let me check maybe 4 of them just to be on the safe side. And there we go, the line properties here on the right. And what do you think? It's 10 meters and 7 centimeters. So since I haven't clicked directly on the middle of the line, I dare say we have fairly good representation of measurements, and we can trust in this reconstruction. Okay, the last but not least is how to export mesh. So the mesh tree is the one I really want. I right click on that and I choose export mesh. There I can choose where do I want to save it, what's the file name, and it has to be in Wavefront OBJ file type. We have a few others available, but for the PVSol it must be OBJ. As soon as I click save, oh yeah, it's the same name, but that's fine. We can export it again. We again have a few options for the parameters. Yet again, quite important is a shift. If you do not change anything, it will be exported with a coordinate system of the world, meaning that it has all the points in really far from the 0 point. So for the PVSol, which operates only in local coordinate system, we have to change it to shift to center, which will make sure that it will reduce our coordinates, but still will leave measurements correct. Precision 6 digits is fine. We can up it to 7 or 8 digits if you really need to, but well, it's kind of choose whichever works for you best. And then we click export, and it's actually very, very quick procedure. There it is. It's exported. So we have a OBJ file in question exported, and over to you, Christopher.
Thank you, Andreas. Thank you. Thank you.
No bother at all.
Now take over and now explain the PV-Sol aspect of what we've just seen. So if you just bear with me, I'll swap my screen over to PV-Sol. And there we are. We're on a PV-Sol screen. Now I'm going to go quite quickly through the PV-Sol part. Like I said earlier, we're doing a longer webinar at midday, and we also run dedicated training courses for PV-Sol. So here's a project I've set up in PV-Sol Premium. I've already got the address of the location, just for a little bit of admin here. Quickly moving on to the system type. We've got 3D selected, Lithuania, and the location of the supermarket is here already. And I've got 1 hour time step just for keeping the speed up for this example. So moving swiftly into the 3D, I'm clicking on the icon at the top, clicking edit. And out of all the choices of entering 3D, if we want to keep things fairly straightforward here, we're going to choose import 3D model. There is an option that you choose the map section and then add a 3D model. I'll just show the outcome of that in a moment, but I want to keep things quite easy here. Just import the 3D model straight. Now we're going to click load. So I'm going to navigate now to the mesh that you saw being generated just before. It's an OBJ file here, all ready to go. Click open. Now this is going to be about 30 seconds. It's a 5 meg file. And just to enforce what Andreas said, that if this step slows down too much, you might want to have a look again at your file size and maybe look at the settings you used in Pixpro. But usually about 30 seconds, maybe 60 seconds. It is going to depend a little bit on your computer. We do suggest a fairly decent computer for doing this type of work. Right, it's now settled down. I can click start, another little delay. Let's see that sort of come in now. You're going to get a message that you can read later. I'm just going to explain that message anyway in a moment. Right up, you might notice it looks wrong. And this is actually quite normal. Just what you can do is right click on it, edit. And I want you to notice the maximum height, so 73 meters. Yeah, that's obviously not right. What we need to do is click the tilt backwards little button here. And then, as you see, the 3D model has now set itself to a maximum height that looks far more sensible. That's quite an important step to do before progressing any further. So, so far the rotation and scale looks reasonable, but we'll just double check that in a moment. So I'm going to click OK. Another short wait as it settles down. Right, now I'm in terrain view and I'm just going to zoom in. I'm overhead. And the first thing I tend to do is I'm going to use this little tool here, which has got an orange color in it. I'm going to select that. I'm just going to create a fairly simple rectangular kind of mounting area. Clicking reasonably quickly and then a right click so that I don't create any more corners. Bringing my mouse over to the left side, I see the sketch mounting surface available. Left click, right click, and edit. And I'm going to lift that surface area just up a tad. Now I'm going to come up 40 centimeters. You can now see the area a lot better. If you don't take this step, you might find your mounting surface is submerged into the 3D model slightly. You've got a tolerance of 1 meter here on this slider bar. Okay, that's now done. I'm now going to tidy up my corners, and I can zoom in and grab a corner and move it around as I need. I'm just making it a little straighter to this back edge, and so on. It's really up to your decision how much time you spend making how perfect this it needs to be. Now that I've kind of got it looking quite nice, I am going to use a right click and make a right angle on the area, each corner. I tend to do this per corner. You can try and do the whole lot together, but I find that tends to distort the shape. So I use each corner there. So each corner is a right angle. It just tidies it up. It looks a bit better. Now you see the white lettering. This is showing you the measurement, and of course you can cross-check any of these polygon measurements against the actual measurement. Andreas used a parking lots there. We could draw a mounting surface on that if we wanted, but for now I'm just going to speed along and just show you this polygon. Now also in this polygon we've got some objects, some 3D type of objects sticking up. They're like ventilation cowls. So I'm going to stay in object view here, and I'm going to use the keep out tool to just kind of click around one of these objects. Right click immediately so I can zoom in. And if I need to, I can tidy up the shape. Not too critical to make that perfect, but you can straighten it up to the edges if you want, and even make the corners right angles. But once I've got one of those, I'm going to right click, going to copy, and I'm just going to add another keep out zone around a couple of these objects, just to stop the modules going in those particular zones. There's other little bits and pieces on this roof. I'm not sure what they all are, but these for sure are 3 key spots I want to keep the modules away from. I'm also going to put a border just around the edge, 60 centimeters. All right, we're ready to put the modules in. So I'm going to move over to module mounting. These modules are going to go on an assembly, a frame. So I'm going to create that assembly, a new assembly that is. And I'm going to add a module on, new module, and I've got a J8 just sitting there ready, 410. So that's modules all set up. 30 centimeters off the lower edge of the roof will do fine. I'll just tilt these back about 15 degrees. Now notice these yellow numbers, they're your reference edges, and I'm going to line these up with the rear edge of this mounting area, and I'm going to type in 180 degrees because actually I want the modules to face the other way. Mounting clearance 2 meters. We can adjust that later. Okay, this looks all right now. Click OK. Click and drag a single unit down. Make sure it's green, and just check it out. Just does it face the right direction? Look about right. To me, that looks good. So now I'm going to fill the whole area. I'm going to use the max out tool. It's this one here, multiple rows. Click OK, and there they are. Modules are on. Going to use the shade frequency tool. Let's do a little bit of shade analysis. Takes a few moments. Now looking at the colors, nothing sort of too red looking. Little look down this spot here. That's probably the worst one, 0.7% there. We could leave it if you want, but of course you can use the edit tools in PVSol here, and if you want to make little cuts, you can do so, and we can remove a section. All right, that looks pretty ready to go. I'm just gonna make sure the project's saved. When you're working in 3D, yeah, you know, you're often pushing the limits of PVSol and your computer, so take care to save your work. All right, let's go to terrain view, and let's come down to a perspective that we can appreciate what we've done. Just gonna maneuver around a little bit. I'm just going to nudge up to see the horizon. There's no horizon at the moment. I'm just going to add that. Left click at the top there, load from PVGIS database. Change your map type if you care to. And here we are. There's the supermarket. Slightly old photograph, but the location is correct. So that's all that we need. There's the data from PVGIS. And you see in the background now the hills and mountains around that location. So get yourself in a nice money shot, as I call it. You're gonna maybe want to choose a nice shot to show your customer. Use the camera function, take a photo, right click and make it the overview picture. That will appear on your report. So this is all looking pretty good to me. Maybe just to finish it off, we'll add an inverter. So I'm going to click Module Configuration. Use the manual import method. Configure it up. I'm going to do a very quick solar edge. There it is. There's the configuration. As normal, you can rearrange the configuration routing. Okay, that looks okay. Quick check of the cable in. Yeah, nice sort of serpentine kind of appearance. Looks like a good one to me. That's a design now that's ready to simulate and calculate a yield. As normal, you would exit 3D at this stage using the adopt data here. But I'm not going to do that. I'm going to leave that on there, and I'm going to just show you the other project I created earlier. I mentioned that you can actually import like a larger 2D image and put your 3D model on top of that. And this is a project I did earlier. It looks very similar to what I just did, but you can expand out, as I say, the areas around your 3D model if you want it. It will take you more time if you ever do that. So I want to just sort of wind this up now, just to finally show you our website. We've got a page dedicated to Pixpro. On the right hand side here, we've got some resources. We've got an FAQ section. I'm just going to open that. It's actually quite short at the moment, but it does summarize what Andreas was saying before about the settings to use. You can try and experiment with the texture size, but maybe start off with the 4K sort of level and build up if you feel more confident with your computer. And try and keep your file size, your OBJ, down to about 250 megabytes at the start if you can, and things should flow easier for you at the start. The other thing we've got is some tutorials on YouTube. And I'll just show you our YouTube channel here. You can see the 2 videos, just nominally about 10 minutes each. And you'll hear my narration over them. So everything you've just seen today will be gone through actually a bit slower, and you can pause and find it easier to learn how to do things, maybe using the YouTube channel. And also we just list the system requirements for Pixpro and PVSol, you need a pretty reasonable computer, I think, for dealing with Pixpro there. So also just sort of bringing us towards the end now, I just want to emphasize on our page, we indicate the pricing for Pixpro. You can see you can start really easily, effectively €60 for the year or €5 per month. Only the cloud processing with this cheaper way of accessing Pixpro. Then you can move up and work into the offline processing abilities. As you see, the price starts moving up. If you want a keep forever license, then please approach us directly and we'll quote you for that. But most people probably would want to start with more of a subscription to see how they get on with the program and the process. And so the pricing is really convenient for that. So we're going to send you guys an email straight after this with a discount code and a link to engage a free trial period for Pixpro. Put those details in on the Pixpro site, and if you go ahead and purchase a license, we'll be able to support you with using PVSol and Pixpro. So I think that brings us towards the end. So any questions, just put them in the chat right now. We're back online at midday today doing a longer session with PVSol. If you're already using PVSol, I would emphasize that what we do at midday is more of just a sales feature sort of tour of the program, but it does last about an hour, and we'll go through all the main aspects of PVSol. But if there are no questions, I hope that was interesting for you, and I'd like to thank Andreas for supporting us with this webinar. But I'm going to put the leaving screen up. You will know our details already, of course, but these are the details for Pixpro as well. So I'm going to now thank you for your attention. Good luck with your projects, and I'll leave this screen up for a few more minutes. All right, so goodbye from me. Bye-bye.
Thank you and bye-bye.